Section 3.7 discusses graphing linear inequalities. So a couple examples of linear inequalities are on the handout that you have in front of you. Here's one, here's another. So it looks a lot like a linear equation, except between the two sides, instead of an equal sign, you've got an inequality. Less than or equal to, less than, greater than, or greater than or equal to. One of those four. Now, part of your work is going to be the same as graphing the corresponding linear equation. That is, if I had an equal sign here or here. But it goes a little bit beyond that. You're going to do a little bit more than just graph a straight line like I have here. The first part of graphing a linear inequality is to graph the line, graph the corresponding equation. So graph y equals 2x. You're going to use a solid line if you have a less than or equal to or greater than or equal to, and a dashed line for a less than or greater than. So from there, though, things change a little bit. It's no longer just graphing a line. We're going to have to decide what side of the line has the points that satisfy this inequality. So you're going to pick a point off of this line and test it in the inequality. See if it works. And then depending on if it works or not, you're going to shade one side of the inequality or the other. To start with, to kind of practice a little bit, let's look at problem number 12. And I've got a region here shaded on our graph. And what I want us to do is I want us to plot these points and decide if they fall in the shaded region or not. That is, do they make this corresponding inequality true or false? So we'll start with 1, negative 3. So 1, negative 3. And that's right down here, right on the edge. But because I've got a dashed line and it's on the dashed line, then it doesn't make this inequality true. It makes it false. It has to land in the region to make it false, to make it true. So the first one is a no or a false. That one's not a great example to start out with, so let's try a different one. Negative 2, negative 1. Clearly that falls inside the shaded region. So that's a yes or a true. Why don't you finish the next two? See what you can conclude. Yes. It landed on a dotted line. If it landed on a solid line, then it would be true. So if it landed on a dotted line, it's false. If it landed on a solid line, it's true. Because solid line says we're actually including the edge. Dashed line says we're not. All right, so let's take a look at the two other ones here. 2 and 3 are up here. And 3 and negative 3 is down here. What about these last two? Yes or no on in each of these? Yeah. Yes and then no. All right, so just a matter of deciding what satisfies their inequality and what doesn't. Negative 2 would be the x. Oh, negative 1, you're right. Thank you. Yeah, it'd be down here. So, something to keep in mind, though. Two mistakes cancel each other out. It's still yes. No, just make sure that moving forward, you make your mistakes in even numbered pairs. That way you still end up with the right answer, okay? All right. Thank you. Let's take a look at a little bit more involved of an example. The graph of y is less than or equal to 2x. So here's the line here. I've already graphed it. Y equals 2x. What we also have to do, though, is decide what side of this line we're going to shade. So to do that, we need to pick a point that's not on our line, and there's a lot to choose from, and test it in the inequality and find out if it's true or false. Is it a yes or is it a no? So there's an infinite number of points to choose from. Can somebody pick one for me? Negative 1 and 1. All right, so negative 1 and 1, I like that one. It's right here. Negative 1 and 1. So that's your x and y. Let's plug that in our inequality and see what we get. So let's see. Is 1 less than or equal to 2 times negative 1? So is 1 less than or equal to negative 2? Is that true or false? False, right? 1 is not less than negative 2. Now, in graphing these inequalities, I want the side of the line that makes the inequality true. So we tested this point, and it didn't satisfy my inequality. So the other side probably should satisfy the inequality. Let's just pick an easy point over here and see that it does. 2, 2. All right. If I put in 2 and 2, let's do that down here. 2 is less than or equal to 2 times 2. Is 2 less than or equal to 4? Is that true or false? That's true. So that's the side of the inequality that I wanted to shade. Now I got to confess to you, really didn't need to test that second point. Once this tested out false, I knew the other side satisfied the inequality. And the rest of your work here is to shade that side of your inequality. So there's 3 basic steps here in working with your linear inequalities. First step is to graph the corresponding equation. Second step is to test a point. And the third step, and this is really important, is make sure you shade the side of the line. I'll tell you right now how I grade these things on your exam. It'll be 2 points for drawing the line correctly. And of course, 1 for using a solid line or a dashed line is appropriate. Another point for testing, and another point for shading. And another point for shading correctly. So if you forget to do the shading and the testing, you're really going to get maybe 1 point or 2 out of 5. So make sure that when you graph inequalities, that you graph and do the shading. All right, let's move to problem number 28. Now we get to do the whole thing for ourselves. It's no longer just, okay, well, let's do part of it. So x minus y is less than or equal to 3. Let's make ourselves a little t-table over here. Kind of squeeze that in. We want to look at the corresponding equation. So that's x minus y equals 3. Now it's up to you how you want to graph this. How are we going to find points here? All right. So what? 5 for x, 2 for y? All right. So magically out of thin air, we got 1. Good. 4 and 1. That would work. I guess what I expected most of you to say was, oh, well, let's set y equals 0 and set x equals 0, and then solve. That's kind of what I expected, but you know what? Both of these work. As long as they work, that's fine. If y equals 0, what does x equal? Can anyone tell? 3. And if x equals 0, y is negative 3. So let's kind of just check out all those points. By the way, I do have rulers here. At least some. It seems like my supply of rulers is dwindling. So it's probably a good day to have a ruler. Let's take a look at our points here. 5 and 2. So that'd be right here. 4 and 1. 3 and 0. And then 0 and negative 3. It seems like those all lie on the same straight line. What kind of a line should I draw? A dash line. So Great, so there's our line. But we're not done. We still have to decide, well, which side of this line we're going to shade. So let's work on that part. How am I going to decide where I want to shade? Don't make Sam do all the work here.
Try to check see if it's true or false.
All right, check true or false. How do we check true or false? What are we going to test?
Pick a point.
All right, Jackie, what's an easy point that's not on the line? 0, 0. Well done. 0, 0 is my favorite test point. All right, if you can use it, it's the easiest. Now notice we couldn't use it in the previous one, right? Because this line passed through the origin. So you can't use 0, 0 as a test point here. We can here. Let's test 0, 0 and see if it's true or false. So test 0, 0. 0 minus 0 less than 3. Is that true or false?
Yes.
That's true. So do I want to shade above and to the left or below and to the right? Yeah, up here, right? Because those points satisfy the inequality. So please, like I said, don't forget the shading on this. It's a big part of getting this problem completely right.
So since it was true, why did he shade this side?
Because that's this side is where the point was. This point satisfied the inequality. So all the points over here are going to satisfy the inequality. Once you test one, you know what happens for all the points on that side of the line. Now, tell you what. Suppose you're going, I'm just not sure. Well, let's pick a point from the other side of the inequality. So can you suggest a point on the other side? 2 and 1 would be up here. How about 4 and negative 4 or something like that? 4 and negative 4. All right, so let's test 4 and negative 4. So we'll test 4 and negative 4. So it'd be 4 minus negative 4. Is that less than 3? Well, 8 less than 3? No. So what that's telling us is that this point doesn't satisfy the inequality. So you want to shade the other side of the line. So the good news is that you only have to test one point. If it tests out true, you shade the same side. If it tests out false, then you shade the other side. So you only ever really have to test one point, as long as you're confident in that point. Good question. Anything else on problem 28 there? Let's try problem number 32. So 3x plus 2y is greater than or equal to 12. Like our previous one, we need to start out by graphing the inequality. And that starts by graphing the line. Thank you. Thank you squared. Okay. You know, it's up to you. You can use 2 or you can use 3. It doesn't matter to me. On this one, the point of the problem is to make sure that you graph the line correctly. It's not a bad idea to use 3 ever, but you know, it's your call. So we're going to start by graphing the equation. 3x plus 2y equals 12. I would suggest, especially on this one, we do it this way. Set x equal to 0, get y. Set y equals 0, get x. Let's start by setting x equal to 0. That wipes out this term. 3 times 0 is 0. Plus 2y is 2y. So if x equals 0, what does y equal? 6. Can you do that again? Do that in your head. If y equals 0, x is 4, right? Because the y term would disappear. You'd be left with 3x equals 12. So 0, 6 is up here. 4, 0 is down here. What's, Micah, what kind of line should I use to connect the dots here? Solid or dashed? Good. Solid line. Let's just draw a nice solid line here. Don, I need a test point. What would be a good test point? 0, 0. Yes, absolutely. My favorite. So let's test 0, 0. Is 3 times 0 plus 2 times 0 greater than or equal to 12? True or false? False. So do I want to shade up here or down here? Above? Yeah, right here. Yeah, so you want to shade on the opposite side of the line here. So let's do that in this very manly pink. Right there. What should happen if I happen to have picked a point up here? How should that test? Should be true, right? If you try 4, 4, 3 times 4 plus 2 times 4 is 20, and that's greater than or equal to 12. So, yeah, it's true. All right, here's a more challenging one. We need to graph, to start with, we need to graph the equation y equals negative 2x, or y plus 2x equals 0. You could try plugging in, say, x equals 0, and then it gives you y equals 0. Well, that's kind of a bummer because that means we can't use our favorite test point. Yeah, hate when that happens. We still need one more point here. What would that be? How can we get one more point? Yes. If you set x equal to 1, I get y plus 2 times 1 equals 0. So y plus 2 equals 0, or y equals negative 2. Good. Anything you plug in for x is going to give you a pretty friendly point for y. So let's see here. We've got 0, 0, 1, negative 2. Let's see if you can catch my mistake here as I work through the problem. I need to connect the points. And then I need to test a point. Oh, there you go. Should be a dashed line. Now, chances are, some of you might make this mistake on an exam, and it's fine. I understand it. It happens all the time. So people do this. They go back like that, and they write a helpful note down here saying, this is dashed. That's fine. That's fine. Not really that worried about it. Just make sure you get that, solid or dashed as is appropriate, because it is a point of partial credit there for you. I can't use my favorite test point. Karanja, which point should I use then? 3, 2. All right, so 3, 2. That's up here. 3, 2. And let's test that in our inequality. So let's see. 2 plus 2 times 3 is 8 less than 0. True or false? False. Victoria, which side of the line should I shade? Good, left side. down here. So the opposite side. What would happen if I picked a point here and tested it in the equality? How should it test out? It should test out true. Yep, should test out true. Okay. Why don't you try a couple? Problems 38 and 46. And then maybe we'll finish up by doing one or two together. Okay, so let's look at these. It seems like most everyone was getting the first one all right. That's good. We're going to graph the corresponding equation. So replace the greater than or equal to sign with an equal to sign. If I plug in an x equals 0, that gives me 4y equals 20, which means y equals 5. Likewise, if I plug in a y equals 0, I get 5x equals 20, so x equals 4. And I get these 2 points, which are going to connect by a solid line. Let's do that here. Now it's a matter of testing points to see where I want to shade. Let's test 0, 0. 0, 0 is a great test point as long as your line doesn't pass through the origin like it does in problem 56. So test 0, 0. 5 times 0 plus 4 times 0. Is that greater than or equal to 20? That's false. So what side of the line should I be shading? This side or above? The above side. Good. The other side from the origin. So up here like that. And that's it. Now the hard part in problem 46 was working with the fact that you've got this that fraction there to deal with. You could start out by setting x equal to 0. That's pretty easy. That wipes out this term. It gives me y equals negative 1. But I need another point. I could choose 1 or 2 for x. Why does it make sense to choose x equals 3? Because 3 divided by 3 works out nice and even. 3 over 3 is 1. 1 minus 1 is 0. So I get these 2 points. Now, unlike the last one, this time I have to use a dashed line. Can I still use 0, 0 as a test point?
Yes.
Sure. So let's test 0, 0. So is 0 less than or equal to 0 over 3 minus 1? Or in other words, is 0 less than negative 1? False. So I want to shade below. I want to shade the opposite side of the line from my test point. Okay. Let's finish up with a couple more here. I'm going to skip problem 56. Let's do problem 68. X minus 1.5 is less than or equal to 0. So it's really x minus 1.5 equals 0 is what we're going to graph. Do I have to come up with a t-table for this? What's the graph of x? Tell you what, let's do it this way. Let's move this to the other side and graph x equals 1.5. What's that graph look like? Somebody trace it out with your hand. Which way? Touchdown or no good? Push it to the right. Vertical. Yeah, good. It's going to be a vertical line. All right, it's going to be a vertical line at 1.5. So, solid or dashed line? Solid line. So there at 1.5. Can I still use 0, 0 as my test point? Sure. So let's test 0, 0. Test 0, 0. Now, there's really only place to plug in for x, right? That's okay. 0 minus 1.5. Is that less than or equal to 0? True or false? True. So am I going to shade to the right or to the left of this line? To the left. In hindsight, you probably could have done this without necessarily, spending the time on the test point. If you wanted to rearrange that as x is less than or equal to 1.5, oh yeah, numbers that are less than 1.5 are to the left. You can do it that way. It's up to you. I'll let you decide if you want to do it somewhat like that with problem number 64. Are there any final thoughts on problem 68 before I move on to 64? You want to shade the side of the line that has points that make this inequality true. So we tested 0, 0, and plugged in 0 for x, found out this inequality was true for that particular point. Since that point lies on the left-hand side of the line, then I want to shade that side of the line. If it tested out false, then I'd be shading the other side of the line. Because one side of the line or the other is going to have all the points that satisfy the inequality. You only have to test one to figure out which one that is. Sure. All right. Problem 64. Why don't you see if you can't crank that out pretty quick. And while you do, I will write down your homework for this section. Palmer? Our test point? 0, 0. There's the origin. Oh, 1.5? Right there. You have a vertical line through that point. Oh, I didn't really graph any points to graph the line. I just knew because I had a line of this form, x equals something is a vertical line here. So I just drew that vertical line through 1.5. We're going to do the same thing here. What's the graph of y equals -3 going to look like? Horizontal line. This time that line is going to be at -3. What kind of line should I draw through -3? Dashed line. Now, again, it's up to you if you need to test points or not. But let's think about this in terms of the inequality. And it's all right for these ones with only one variable. It's a little tougher to do with two variables. But where am I going to find points that are greater than -3 along the y direction? Above here or below? Above. Now you can test points and you get that same conclusion. If you test, say, 0, 0, 0 is greater than -3, you shade above. But these, if you'd like to, you can look above and see them. Now, if you're noticing, if you're paying attention, we did a little extra practice here with horizontal and vertical lines here. We did some the other day when we were graphing and working with slopes. What's the slope of this line? Got a couple voices. Anyone also? Greg? 0. Nick, how about this one? Undefined. So I'm trying to emphasize that for no particular reason other than you have a test on Monday. So here's your homework. Good luck with that.